Hi everyone, this is Shruti Pandey from the Department of Chemical Engineering at IIT Kanpur, and I welcome you all to Lecture 12 of Chemical Kinetics. So we are already done with the chapter, but we are discussing the numericals. So last class also we discussed a few questions. So we'll just start right away. So the question says the reaction between A and B is first order with respect to A and zero order with respect to B. So there is some reaction. Suppose they have not given the reaction. So, as per the question, the order with respect to A is 1 and order with respect to B is 0. Okay. And they have provided you with a table for the concentration of A and B and the initial rate. Okay. So, there are a number of, they have done the experiments number of times and अच्छा, what they see general numerical कैसे आता है कि they give you the initial rate and the initial concentrations for the different experiments, and you have to in a tabular format, and you have to use that data to find the order of the reaction. But here what you have to do is they have given you the order, they have already provided you the order, the individual order, and now they'll be asking you to find the initial concentration and the initial rate by providing a table. So let me just write down that data. This is the concentration of A. I mean, the units are mole per liter, the normal units. This is the concentration of B, and this is the initial rate. Okay? So they have not given you the complete table, because if they'll give you the complete table, then there will not be anything left to be found out. No? So that is why 0.1. They have given a dash over here. Then they have given 0.4 and then again a dash. Similarly for B, they have given 0.1, 0.2, 0.4 and again 0.2. For initial rate, which is in mole per liter per minute. ठीक है, तो यहाँ पे मैं यूनिट्स मेंशन कर देते हैं. मोल पर लीटर मिनट, इट इज नॉट इन सेकेंड्स. ठीक है. इनिशियल रेट है 2 इंटू 10 to the power -2, 4 into 10 to the power -2, then dash, then 2 into 10 to the power -2. And they have asked in the question that you need to fill all these blanks which are there in the table. So एक तरीके से it has a kind of a reverse question. You have to apply the same logic, but you just have to fill the table. So as I told you, as a similar question we have done in the previous lecture also, but there I have told you that how you can write down the equations and then divide for a particular experiment. You have to write a separate equation, and then you will divide that equation, the any two equations, which will be having the same initial rate for one of the components. ठीक है. So and then you can divide those equations to get the power. ठीक है, वो प्रॉपर जो तरीका होता है वो आई हैव ऑलरेडी डिस्कस्ड. To see what is happening is they have given the rate will be some k, क्योंकि फर्स्ट ऑर्डर है तो दिस a और b to the power 0. The concentration of b will be 0, so that will be 1. So basically the rate is independent of the concentration of b. ठीक है, तो आप b का कंसंट्रेशन कुछ भी चेंज कर लो, उसे फर्क नहीं पड़ेगा. ठीक है. तो अगर आप इनिशियल, आई मीन इफ यू जस्ट आई एम आल्सो राइटिंग द कॉलम नंबर ओवर हियर, or you can call it the experiment number. Okay, so if you just look at the first column, A and B both are 0.1 and you have been given the initial rate. Now in the second column, you will change A because the rate is independent of B. तो आप B को आपने डबल कर भी दिया है तो उससे फर्क नहीं पड़ता, बट द रेट हैज चेंज्ड. ठीक है, तो इवन इफ यू डोंट लुक एट द कंसंट्रेशन ऑफ बी, यू जस्ट इग्नोर द कंसंट्रेशन ऑफ बी, और आप देखो कि रेट जो चेंज हो रहा है वो सिर्फ ए की वजह से चेंज हो रहा है. तो एक्चुअल में द रेट इज गेटिंग डबल्ड ऑफ द इनिशियल वैल्यू ऑफ दिस कॉलम नंबर 1 वैल्यू से जब आप कंपेयर करोगे तो द रेट इज गेटिंग डबल्ड. का मतलब द कंसंट्रेशन इज आल्सो गेटिंग डबल्ड बिकॉज द ऑर्डर इज 1. So that is why the proportional rate will be proportional to the concentration of A. Directly proportional to A. This. Okay, so because the initial rate is getting doubled, so the concentration of A will also get doubled. अभी तो 0.1 था, so now it will be 0.2. ठीक है, तो अगर आप यहाँ पे इसको लिखना चाहो तो it is in blue, so this will be the value over here 0.2 because it is getting doubled. ठीक है, now coming to the column number 3. Again, you compare it with first column or you can compare it with second column, doesn't matter. So if you just um, suppose we are comparing it with the first column, so the concentration of A is multiplying by 4. मतलब पहले 0.1 है and now it is 0.4. So basically it has become 4 times the previous value, 4 times. The value of B has also become 4 times, but because the rate is independent of B, it doesn't matter. ठीक है, तो आप B को neglect कर दो, ignore कर दो. Now because A has become 4 times, so the rate will also become 4 times. Initially it was 2, so now it will be 4 times. 4 times. 4 to the 8. So here it will be 8 into 10 to the power minus 2. ठीक है, सिंपली आपको इसको into 4 कर देना है, that's it. अगर आप 2 से कॉलम नंबर 2 से कंपेयर करते हो तो बिकॉज इट इज 0 comparing to 0.2, the rate or the initial concentration of A has doubled from 0.2 to 0.4, so that is why the rate will also get doubled. ठीक है, now coming to the column number 4. So comparing it with the first column, you see that the rate is same. The initial rate is वहाँ पे भी 0.02 है and here also it is 0.02. So it has not changed. So that means because it is independent of B, the concentration of B, so आप B को फिर से ignore करोगे and you will just look at the concentration of A. Concentration of A will also not change. So this will be 0.1 again. So the values, there are three blanks. So the answers I am writing in this inside the rectangle. तो सी आपने देखा कि कुछ कुछ क्वेश्चंस के लिए if you are able to directly just by looking at the values or the numbers you can directly make out the multiplication factor or the division factor, then आपको पूरा इक्वेशन लिखने का भी जरूरत नहीं है. ठीक है, आप डायरेक्टली आंसर देख सकते हो. So this was the first question. Coming to the next question. So it is a graphical question. Obviously, I mean, you can have a graph paper and solve it properly, but I'll discuss how to do such questions. Okay, so the question says, they have first given us the reaction. So first of all, we will write down the reaction. In 205, it will decompose to give 4NO2 plus O2. Okay. So the reaction is happening in the gas phase, and they have also provided us the temperature at 318 Kelvin. Okay, and then they have given us the experimental data of time versus the concentration of N2O5. How the concentration of N2O5 is changing with time. N2O5 is the reactant. Okay, so I will write down the table first. This is time, or you can take capital T, small t. This is, and here they have given 10 to the power 2 into the concentration of N2O5. So instead of writing 10 to the power minus 2 everywhere in the data, in all the columns, they have simply written 10 to the power 2 in the heading itself. ठीक है, और यहाँ पे ये चीज मोल पर लीटर में है. So time is 0, 400, 800, 1200, 1600, 2000, 2400, 2800, and 3200. Now the concentration would be, initial is given as 1.63, 1.36, 1.14, 0.93, 0.78, 0.64, 0.53, 0.43, and 0.35. Okay, so this is the data that they have provided. Now, the first part says that we have to plot N2O5. I mean, इसमें कुछ ऐसा tricky नहीं है. Simply they have given the data and they are asking you to plot the concentration of N2O5 versus time. ठीक है, तो you don't have to do anything. आप simply graph paper लोगे और you know write down the x-axis. In x-axis you will plot time, and in the y-axis you will plot the concentration of N2O5. ठीक है, so that is fine. Now they say that find the half-life period for the reaction. Find half-life, because it is I mean, because they have provided you with the data. ठीक है, तो you have to use data to find the half-life. अभी आपको यहाँ पे I mean, you don't have to use a formula, because still you do not know the order of the reaction. They have not given you the order. ठीक है, so that is why I mean, if you know the order of the reaction, then you can find out the half-life directly by from the the formula that we had derived using the integrated rate law. But because you do not know the order, and it is an experimental question, so you will use this data, or you will use that graph to find out the half-life. Okay, I'll tell you how. Then they have given, now you have to plot the graph between log N2O5 versus time. Okay, after that, what is the rate law? Then they have asked to find the value of K. Then find the half-life again from K and compare it with B. ठीक है, तो दे आर बेसिकली व्हाट आप देखो इस पूरे क्वेश्चन को, व्हेन you will read all the parts one by one, you will see कि they are actually what they are trying to do is initially वो इस प्लॉट से हाफ लाइफ निकलवाएंगे. ठीक है, एंड देन आफ्टर डूइंग यूजिंग लॉग दे आर आल्सो गोइंग टू they want you to find the half life from other technique, and then they want to compare the two half lives. So let's see what happens over here. ठीक है, तो first what they have asked, you have to plot simply N2O5 versus T. ठीक है, तो when you will plot N2O5 versus T, the plot will look like this. I mean, you can arrange a graph paper and plot it on your own. ठीक है, so here what you will take, this will be time in seconds. This आप N2O5 plot कर लो, या it would be better because I mean obviously you cannot plot 10 to the power minus 2 data, so आप यहाँ पे जो as it is जो value दे रखा है N2O5 into 10 to the power 2, जो डेटा में as it is value है टेबल में, you simply plot that. ठीक है, तो आप क्या करोगे, यू विल आपके पास एक्स एक्सिस वाई एक्सिस होगा ग्राफ पेपर में, सो आप उसको सिंपली यू विल राइट डाउन द वैल्यूज. ठीक है, तो व्हेन यू विल प्लॉट दिस डेटा, आप देखोगे कि दिस डेटा इज नॉट इन अ स्ट्रेट लाइन. ठीक है, तो वो जो पॉइंट्स होंगे, यू डोंट हैव टू जॉइन दोस पॉइंट्स यूजिंग अ स्ट्रेट लाइन, वो पॉसिबल नहीं होगा, या आपको यहाँ पे बेस्ट फिट कर्व नहीं बनाना. ठीक है, तो आप जब उसको एक्चुअल में ज्वाइन करोगे सारे पॉइंट्स को, तो दोस पॉइंट्स विल लुक लाइक समथिंग लाइक दिस. किसी पर्टिकुलर पॉइंट से शुरू होके नो मतलब दे विल एक्चुअली फॉर्म अ कर्व. ठीक है, तो मतलब ऐसे पॉइंट्स होंगे. इन सच क्वेश्चंस यू नेवर हैव टू ड्रॉ द बेस्ट फिट लाइन. ठीक है, जो डेटा पॉइंट्स होंगे दे विल देमसेल्व्स लाई ऑन दैट कर्व. ठीक है, तो इट इज अ कर्व, नॉट अ स्ट्रेट लाइन. ठीक है, so because N2O5 versus time is a curve and it is not a straight line. ठीक है, तो while we were deriving the integrated rate law, what we discussed was in the case of zero order reaction, when we plot the concentration versus time graph, we get a straight line. ठीक है, तो वो जीरो ऑर्डर रिएक्शन का एक प्रॉपर्टी होता है कि हर जीरो ऑर्डर रिएक्शन के लिए इन irrespective of the type of reaction, if it is zero order, then on plotting the concentration versus time graph, you will always uh, you'll always get a straight line. ठीक है, but similarly for the when we are doing it for the first order reaction, so if the reaction is first order, when you will plot the log of the concentration versus time graph, then you will get a straight line. So these are to the properties of the order of the reaction. ठीक है, तो इसका मतलब अगर if this graph would have been a straight line, ठीक है, if these data points would have been lying on the straight line, perfect straight line, then we would have concluded that it is a zero order reaction. Sorry. ठीक है, अगर ये स्ट्रेट लाइन में होते तो देन हमें कुछ और जरूरत ही नहीं था. दैट वुड कंक्लूड कि दिस इज अ जीरो ऑर्डर रिएक्शन. बट बिकॉज इट इज नॉट इन अ स्ट्रेट लाइन, सो दिस कंक्लूड्स दैट दिस इज नॉट अ जीरो ऑर्डर रिएक्शन. फर्स्ट ऑर्डर है ये हमें नहीं पता, सेकेंड ऑर्डर है ये भी हमें नहीं पता, लेकिन जीरो ऑर्डर नहीं है, बस हम ये कह सकते हैं. ठीक है, सो आई मीन what can we deduce is because this versus time is not a straight line. So this so reaction is not a zero order reaction. Okay, that's it. The actual order we still don't know, but it is not zero order. Okay, now what they say is find the half life. Okay, अब they have not still talked about the order of the reaction. Okay, so what they want is the half life. So what we will do now? What is half life? Half life is the time which is required for the concentration of the reactant to reduce to half of its initial concentration. Okay, so basically, what is the initial concentration? 1.63. Okay, so when so at some time the concentration should reduce to half. So the half of 1.63 is 0.815. Okay, so basically from the graph,
Recording stopped. Recording in progress.
There will be some point with 0.815, right? So 1.63 ka half is 0.815. So suppose this point is 0.815 वाला point. ठीक है, this is the half of the initial concentration. ठीक है, तो आपको क्या करना है, इस point से you have to draw a straight line which will cut the curve over here. ठीक है, and then you have to draw this line over here, and this will correspond to some point, some time. So this time is the half life. ठीक है, तो आपको कोई कैलकुलेशन नहीं करना है यहाँ पे, आपको ग्राफिकली निकालना है हाफ लाइफ. ठीक है, तो यू विल यूज दिस टेक्निक. When the concentration is 0.815, at what time is it? So that time is the half life of the reaction using the data which has been provided. ठीक है, so okay. So for the B part, for N2O5, it is 0.815 mole per liter. Corresponding half life जो निकल के आया, that would be around, if you do it from the graph paper, that would be around 1450 seconds. ठीक है, okay. Next, they are asking to plot log N2O5 versus time and then find the rate law. Okay, so what we will do is, next, they will again plot this graph. यहाँ पे now आपको क्या प्लॉट करना है, log N2O5, and here you will take time. ठीक है, तो आप क्या करोगे, you simply you make a table which will be like this. This is the time in seconds. This is the actual N2O5 value जो given है डेटा में, and then you make a third column of log N2O5. ठीक है, and you complete this table and you will get the final values of log N2O5 at a particular time. ठीक है, तो अब आप उस चीज को प्लॉट कर दो. So on plotting, now you will see कि ये जो पॉइंट्स आएंगे log N2O5 के, they will be lying on a straight line. ठीक है, so after joining those points, you will get a perfect straight line. So that means कि when we are plotting log N2O5 versus time, it is giving us a straight line. And this is the property of the first order reaction. कि first order reaction के integrated rate law में we get the log term, right? Log of A naught divided by A. So this is the property of getting the straight line for log A versus time. Okay, so this basically means that the order of the reaction is 1. This is a property of the first order reaction. Okay, so the next part is to tell us what is the rate law, to write down the rate law. Okay, the rate law will now be rate A and first order with respect to the reactant N2O5 to the power 1. Then the next question says find the value of the rate constant and then half-life from K. So this will be, first we need to find out the rate constant K. Okay, so from that property, from the integrated rate law, इंटीग्रेटेड रेट लॉ क्या कहते हैं? आई मीन आई विल राइट डाउन, इट इज KT इज इक्वल टू, and because of log here this will be the numerical factor of 2.303. ठीक है, so according to this plot, when you linearize this plot, then what you will get is the slope. So according to this integrated rate law, it says that the slope of the जो भी हमारा curve आया straight line आया है उसका जो slope है that is given by this expression, because पहली बात तो it is a negative slope, so it will be minus k divided by 2.303. ठीक है, so this is the slope, this is actually में this ये जो पूरा expression है slope का, this is coming from integrated rate law. Now you will use this expression and you want to find out the slope from the original graph. ठीक है, तो हम क्या करेंगे, जो एक्चुअल में इसका स्लोप होगा वो फाइंड आउट करेंगे। जैसे भी लाइन का स्लोप निकालते हैं तो क्या होता है, इट्स dy/dx, so this is y2 minus y1 by x2 minus x1. So you will use this formula and you will find out the slope. ठीक है, तो यहाँ पे when you will do the calculation, it will be around this. The slope, this is coming out from the graph. ठीक है, तभी मैंने ग्राफ के बगल में लिखा है. So this value is coming out from the graph and this is the expression coming out from the integrated rate law. You have to equate both of them, and on equating आपको इसको इससे equate कर देना है and then you will find out the value of k. So according to this whole calculation, k comes out to be 4.82 into 10 to the power minus 4 per second. ठीक है, and the units are also matching because we are using the first order rate law. ठीक है, तो यहाँ पे per second आ रहा है. ठीक है, so this is the value of k. Now the last um, part says that you want to find out the half life, and you know that half life for the first order reaction is it can simply be found out by this formula. So 0.693 by k, and on putting the values you will get 1438 seconds. ठीक है, I mean it's not clear, I'll erase it. One four three eight seconds. Now what they want to want you to do, they want to compare. अब यहाँ पे जो आपने half life निकाला था, okay, I have not, okay, I have written it in the next page itself. So here see, from in the first graph जो उन्होंने यहाँ पर निकाला था, that was 1450 seconds, and here it comes out to be 1438 seconds. So obviously the this half life, that we have found out in the last step, that is the correct half life because वो हमने formula से और slope से निकाला है. ठीक है, and वो जो पहले वाला था, that we were just checking कि whether the reaction is first order or the zero order reaction. So this is the complete procedure. You must now have understood ki why knowing about the graph or the graphical properties, knowing about the slope of the graph, I mean what the slope represents, what the y-intercept represents is important. Okay, so you must be aware of everything. Coming to the next question. Okay, so this was the second question. This is third. The question says that the rate constant for the first order reaction is 60 per second. So first of all, the first order reaction उन्होंने बताया है in the question, and the rate constant की value they have given, that is 60 per second. Now they are saying how much time will it take to reduce the initial concentration of the reactant to its 1/16th value. So I will write it down. How much time it will take to reduce the initial concentration of the reactant to its 1 by 16th value. Okay. So, I mean, if the initial concentration is A naught, so the final concentration will be 1 by 16th A naught. That's it. Okay. So, how will we find out? We will, because they have already given you the order, so we can directly use the integrated rate law. For first order reaction, what is the rate law? It is time is equal to, if we write it in terms of log, 2.303 by k log A naught initial है और A is the final. Now they have not given you the values. They have not given you the initial concentration, the numerical value they have not provided. Neither they have, nor they have given you the final concentration of A. They have given in terms of the relative, in relative terms. So we will simply put the values. It's very easy. Two 2.303 by K is already given 60 per second log. You keep it A naught as it is. Now, according to this statement, the final concentration is, because it is reducing to 1/16th of its value of the initial concentration. So it is basically 1/16th of A naught. The final concentration of A is 1/16th of the initial concentration. So आप यहाँ पे simply 1/16th डाल दो, 1/16th of initial concentration A naught. Okay, so this 16 is in the denominator, so it will go above. It will become the numerator, and this A naught will cancel out. ठीक है, तो फाइनली जो आपको एक्सप्रेशन मिलेगा, that would be 2.303 by 60 log of 16. That's it. ठीक है, so I mean it's a numerical value. On solving it, we will find out the time to be approximately 4.6 into 10 to the power minus 2 seconds. It is 4.6 into 10 to the power minus 2 seconds. Okay. So this is the final value of time which was the question asked. Now, next question. This is an interesting question because, I mean, it's not difficult, but the language of the question is such that people, might think that it's difficult. Because if you're not able to understand the language of the question, then, I mean, even the simple question appears to be very difficult. Okay, so I'll explain you. I'll first write down the question and I'll explain you the question, what it is saying, and then you will automatically understand that what you need to do. So I'm reading down the question first. During the nuclear explosion, one of the products is 90 SR. with a half life of 28.1 years. So I keep on writing. I mean, that would be easier, I think. I will write this question because it has a very different kind of a language during nuclear explosion. One of the product is 90 SR with half life of 28.1 years. ठीक है, so this is the half life. जैसे हम लोग सेकंड्स में रिएक्शंस के लिए हाफ लाइफ देखते हैं, वैसे दिस इज इन ईयर्स. आई मीन इट इज इन टर्म्स ऑफ टाइम. So nothing to worry about till here. Now they are saying if 1 microgram, this is mu. The symbol mu represents 10 to the power minus 6. ठीक है, तो इट्स अ वेरी स्मॉल क्वांटिटी. जैसे हम मिलीग्राम के लिए m यूज करते हैं, वैसे ही फॉर माइक्रो फॉर 10 to the power minus 6 we use this symbol mu. So it is 1 mu g or 1 microgram of 90 SR was absorbed in the bones of newly born baby. Instead of calcium. C is for calcium. How much of it will remain after 10 years and 60 years if it is not lost metabolically? ठीक है, so how much of it remains after 10 years and 60 years? That means they are asking for 2 times. ठीक है, आफ्टर 10 इयर्स क्या होगा और 60 इयर्स क्या होगा. सो बेसिकली ये भी कुछ नहीं है. दिस इज काइंड ऑफ T1 एंड दिस इज T2. मतलब सम अदर टाइम, 2 टाइम्स के लिए दे वांट टू नो दी कंसंट्रेशन. तो सी, ये जो फर्स्ट लाइन है, दैट ड्यूरिंग द न्यूक्लियर एक्सप्लोजन वन ऑफ द प्रोडक्ट्स इज 90 SR विद हाफ लाइफ ऑफ 28.1 years. So first of all, you should know कि this nuclear explosion kind of a thing, it is always first order reaction. They have not mentioned it over here. ठीक है, कई कई क्वेश्चंस में, लाइक इन द प्रीवियस लेक्चर वी आल्सो डिड अबाउट द रेडियोएक्टिव डीके. ठीक है, so there also I told they have not mentioned, but you must be aware that radioactive decay always is a first order reaction. ठीक है, similarly here also I would recommend that you should be aware that the nuclear explosion kind of reactions, they are also first order reactions. ठीक है, तो even if they don't mention, you should know कि ये फर्स्ट ऑर्डर रिएक्शन है. ठीक है, now moving ahead, because you know कि it is a first order reaction and they have provided you with the half life. ठीक है, so for the first order reaction the half life is 0.693 by k. ठीक है, तो even if you know the half life you can find out the value of rate constant for the first order reaction. ठीक है, तो आपको क्या करना है, सिंपली आप हाफ लाइफ का वैल्यू उस फॉर्मूले में डालिए एंड यू विल फाइंड आउट द rate constant k for this reaction, for the nuclear explosion reaction. Now you will get k. Now you read the second part of the question. It says that 1 microgram of 90 SR. आप 90 SR भूल जाओ, आप सब बस इतना सोचो कि ये कुछ एक A है, मतलब it's a reactant and it is being absorbed in a newly born baby in his body. in a newly born baby की bones में absorb हो गए. So basically this is the initial concentration. ठीक है, क्योंकि न्यूली बॉर्न बेबी है और 10 साल बाद और 60 इयर्स बाद क्या होगा एक्चुअली. ठीक है, सो दिस 1 माइक्रोग्राम इज द इनिशियल कंसंट्रेशन. ठीक है, यहाँ पे इन्होंने कंसंट्रेशन नहीं दिया है. because we are dealing with एलिमेंट, तो इन्होंने यहाँ पे ग्राम्स में दिया है. दिस इज ग्राम, राइट? So this is the mass. No, so instead of concentration, they have given in terms of mass. कोई बात नहीं, we'll do the same thing. बस हम concentration की जगह पे mass डाल देंगे values में. So we'll also get the answer in terms of mass. ठीक है, so no need to worry. So this is the initial mass, 1 microgram, and they have given you the time. ठीक है, तो क्या क्या दिया इन्होंने? First, they have given you the half life, which is 28.1 years. So with this data, what you will do is, uh, K will be, for the first order reaction, it is 0.693 by half life. So this, on putting the values, 0.693 by 28.1 years, when you will put, and the value, sorry, the unit would be years negative. Okay, so this is the value of K that will be using in this question. Now, because again, you know that it is a first order reaction, so आपको क्या करना है? Simply use the integrated rate law, because you have to find out the value, the final concentration at a particular given time. Okay, so time has been given, so we will write down the rate law first. Time is 2.303 by K. Log of some A naught, initial concentration by final concentration. Okay, so this is the integrated rate law for the first order reaction. Now, for this part, just for 10 years, so you take this T value to be 10 years. You know the value. See, in this equation, आपको अभी क्या क्या पता है? You know T. It is being given in the question. You know the value of K. You know the initial concentration. I mean, not in terms of concentration, but in terms of mass. 1 microgram. ठीक है, so that is 1. So you will put 1 microgram over here. But you do not know the final concentration. This you don't know. ठीक है, तो आपको A, the concentration of A you need to find out. Okay, so when you will put all these value and you will find out the concentration of A. So let's see what happens. Here we will put 10, 2.303. K will be 0.693 into 28.1 will be log. यहाँ पे आप 1 डालिए, that's it. And यहाँ पे A. ठीक है, so you know this ये वाला जो है, because it's 1 upon A, so this will become minus. मतलब this A, when it will go up, it will become 1 upon A will become A inverse, right? And when you will take, because it is in power, so -1 is power, so because of the property of log, this will become minus of log A, like this. ठीक है, the property log में क्या होता है कि जो पावर होता है अंदर, that comes outside, that comes in front of log. This is the property of log, so this will become minus log A. So when you will remove the minus sign, this will be minus will go over here, and all the other things would be like this. 0.693 by 2.303 into 28.1. ठीक है, you simply find out the value and take the anti-log of that value, because आपको A निकालना है जो कि which is inside log. ठीक है, तो when you will take anti-log, so ये log जो है ये हट जाएगा. It will go to the outside, like will take anti-log, and the value would be, the concentration of A will come out to be, the value will come out to be 0.781. एंड बिकॉज जो हमारा इनिशियल मास है, इनिशियल कंसंट्रेशन, दैट इज इन टर्म्स ऑफ माइक्रोग्राम, सो जो फाइनल वैल्यू आएगा दैट विल आल्सो बी इन टर्म्स ऑफ माइक्रोग्राम, लाइक दिस। ठीक है, तो यू नीड टू पे अटेंशन टू द यूनिट्स। The unit should be constant, you should be uniform in the whole question. So this is the final concentration after how much of it will remain after 10 years. Because obviously जैसे reaction में after some time the concentration decreases. Similarly here also in the body of that newborn baby, the concentration of SR will reduce with time. So after 10 years it has reduced from 1 microgram to 0.78 microgram. That's it. ठीक है? Now you have to perform the same thing for 60 years also. So I'll not calculate it. I'll simply write down for 60 years. It would be 60 would be over here. Zero point. And as I told you that log 1 upon r will become minus log r. ठीक है, तो यहाँ पे ये माइनस साइन यहाँ पे आएगा and this will be log r, log e. ठीक है, and when you solve for a here, तो यहाँ पे जो a आएगा that would be, no, on calculation that would be 0.2278 obviously in micrograms. So after 60 years, this will be the amount of SR which is left in the body of that newborn baby after 60 years. Okay, so next question. Next question says that for a first order reaction, so okay, they have given you the order of the reaction. We need to show that the time required for 99% completion is twice the time which is required for the completion of 90% of the reaction. So, in simple terms, the question is asking us that we need to prove it that the time which is required for the completion of 90% of the reaction, if it's T, uh, then the time which is required for 99% completion is twice. Then it should be 2T. मतलब 90% completion of the reaction के लिए, if time is T, then for the 99% completion, time should be 2T. It's just double. I mean, you must be thinking कि how can it be possible? If 90% reaction होने के लिए it's taking 10 minutes, then 99% होने के लिए it will take 20 minutes. It's just double. So ऐसे सुनने में it might appear to you that it is not possible, but yes, it is. ठीक है, so we'll just derive this. We'll try to prove this. ठीक है, so how to prove this? कुछ नहीं करना है because they have already given you the order, so आप directly integrated rate law use कर सकते हैं. In the integrated rate law, because see, first of all, you should understand this thing. If in the question they are asking for the completion term is there, मतलब if the reaction is completing 90%, you have to think कि what is being left, what is remaining. तो 90% complete हो रहा है, तो इसका मतलब 10% बचा हुआ है. ठीक है, तो बिकॉज जो बचा हुआ वैल्यू होता है वो हमें डालना होता है इंटीग्रेटेड रेट लॉ में. तो जो फाइनल कंसंट्रेशन है दैट मीन्स कि कितना रिमेनिंग कंसंट्रेशन है. तो हमें कंप्लीशन का परसेंटेज नहीं डालना होता, हमें वी नीड टू यूज द remaining amount, the percent, the remaining amount of the reactant, and not the used amount of the reactant. ठीक है, prove that time for 99% completion is twice the time for completion of 90% of the reaction. ठीक है, we need to prove this. ठीक है, तो okay, because okay, I have not mentioned over here that n is first order reaction. They have given in the question. ठीक है, तो because it is first order reaction, so what we will do is we'll first start with the equation, integratory law. 2.303 by k log a naught is the initial concentration, a is the final concentration. ठीक है, तो I would like to again say कि ये क्या होता है, ये है final concentration. Or we can say कि if some amount has been used, we can also say that it is the remaining amount. ठीक है, तो ये जो परसेंटेज कंप्लीशन के टर्म्स में दिया हुआ है, वी शुड नॉट यूज दैट, बिकॉज कंप्लीशन मतलब व्हाट हैज बीन यूज्ड. तो 99% कंप्लीशन मतलब 99% ऑफ द रिएक्टेंट हैज बीन यूज्ड, so only 1% of the reactant is remaining. So the final concentration should be 1% of the initial concentration. ठीक है, so how will we do this? So suppose we want to do it for 99% first. ठीक है, for 99% completion के लिए how will we write down this? For 99% completion, remaining is 1%. ठीक है, or you can say कि if 100 was the initial, if 100, sorry, if initial is 100, then final would be 1% of 1% of 100. Remaining is 1% of 100. मतलब remaining कितना है 1. ठीक है, तो when you put this value, तो जो आपका टाइम आएगा, let it call as T1, it would be 2.303 by K. Obviously you don't know K, they have not given you the value of K, and you know you need not I mean you don't require it also. Log initial concentration आपने क्या माना 100 according to this convention, and the final concentration which is remaining is 1. ठीक है, तो basically you need to find log 100 on solving, because you don't know K, so it's fine. This will be 2 into 2.303 by K. ठीक है, in terms of K this is T1. Now similarly we for 90%, remaining is 10%. ठीक है, तो अगर if we go by this convention, see if it is given in terms of percentage, ठीक है, you can take it as 100, the initial concentration to be 100, no problem, because percentage is, you know, the total value is considered as 100. ठीक है, but if it's given in terms of fraction, आप डायरेक्टली वैल्यू डाल सकते हैं, बिकॉज आई मीन देन दी दिस ए नॉट टर्म्स विल कैंसल आउट ऑन बोथ द डिनोमिनेटर एंड न्यूमरेटर. ठीक है, तो अगर फ्रैक्शन में है, सो यू कैन सिंपली पुट द वैल्यूज. इफ ए नॉट इज 100, ए विल बी 10%, remaining is 10%, right? A will be 10% of 100. So it will go away. So final would be 10. So T2 would be 2.303 by K. Log of initial was 100 and final is 10. Okay, so log 10. Log 10 will be 1. So T2 would be 1 and 2.303 by K. So simply, I mean, T1 is 2 times of this value and T2 is this value. So basically, मतलब in place of 2.303 by K we can keep T2. ठीक है, तो on replacing जब आप रखोगे, so this T1 will be equal to 2 times of this value which is T2. ठीक है, so that is why T1 क्या है? T1 is for 99% completion. So we can say this statement that the time which is required for 99% completion is twice for the time required for the 90% completion of the reaction. ठीक है, but this thing is not common. I mean, it is not a general statement. This statement is only for a first order reaction. So, because we have used the first order integrated rate law to derive this or to reach to this conclusion. ठीक है, ये चीज will not be followed by zero order or second order reactions. So only for first order reaction. ठीक है, so this will be all for today. I also need to do several other questions, so we'll do it in the next lecture. Thank you.